Here we go. The following Zoom session is being recorded and will appear later today on our YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we start the final chapter, chapter 11. We're going to look at section 11.1. And the topic of today is called composition. Composition is an operation like addition, subtraction, multiplication, division. We have composition. The symbol for composition is a circle. And what we're going to look at to start with, let's say we want to compose function f with function g. So what we would say is f composed with g of x, which is equal to f of g of x. Now, the process isn't really complicated. It's understanding the notation, how it works, the order in which you do things. That's the thing you got to get straight. But the actual doing of it is not a difficult situation. So f composed with g of x means that for some function f and for some function g, we're going to evaluate f at g. And again, that seems kind of complicated, but we'll look at some examples to get things straight. All right, so suppose we have f of x equals 2x plus 1, and g of x equals x squared minus 1. And we want to find the following: f composed with g of 2. So what that means is we want to evaluate f of g of 2. So first of all, or next, let's find g of 2. G of 2 is 2 squared minus 1, 4 minus 1, or 3. Since g of 2 is 3, that goes in the place of g of 2. So f of g of 2 now becomes f of 3. F of 3 is 2 times 3 plus 1, which is 6 plus 1, which is 7. So final answer is 7. So f composed with g of 2 equals 7. You okay with all of that? All right. Using the same f of x, which is 2x plus 1, and g of x, which is x squared minus 1, let's find g composed with f of 2. So we did f composed with g of 2. Now we'll find g composed with f of 2. So this is g of f of 2. So we've switched the order. F of 2 is 2 times 2 plus 1, which is 4 plus 1, which is 5. So that goes in here. So then we get g of 5, which is 5 squared minus 1, 25 minus 1, 24. So g composed with f of 2 is 24. You okay with that? Notice that f composed with g of 2 does not equal g composed with f of 2. So in general, the operation composition is not commutative, okay? Now, I say in general, there are some specific cases, and we'll be looking at those tomorrow, but in general, it's not commutative, because remember, addition is commutative, multiplication is commutative, composition is not commutative. Okay, let's take a look at some more examples. Again, we're going to use f of x equals 2x plus 1, and g of x equals x squared minus 1. And let's find g composed with f of 1/3. So g composed with f of 1/3 equals g of f of 1/3. So let's start out by finding f of 1/3. F of 1/3 is 2 times 1/3 plus 1, which is 2/3 plus 1, which is 1 2/3, or let's just go with 5/3. Okay. So 5/3 goes in the place of f of 1/3. So now we get g of 5/3, which we're going to put in there, which is 5/3 of the quantity squared minus 1, 25/9 minus 1, 25/9 minus 9/9, which is what, 16/9. So we have g composed with f of 1/3 is 16/9. All right, with that. Okay. Let's see here. Here's some more examples. Now, let f of x equal 3x minus 2 and g of x equal x squared plus x. Find each of the following. Okay. Let's find f composed with g of x. So before we've been putting in a specific value of x, now we're just going to leave it as x. So f composed with g of x equals f of g of x. But g of x is x squared plus x, so that goes in there. So now we have f of x squared plus x. So far, so good. So this would be what? 3 times the quantity x squared plus x minus 2, which is 3x squared plus 3x minus 2. And so we get that. Okay. Let f of x equal 1 over x and g of x equal 1 over x squared. Find g composed with f of 1/3. That's equal to g of f of 1/3. Well, f of 1/3 is 1 over 1/3, which is 1 divided by 1/3, which is 1 times 3 over 1, which is 3. So 3 goes in the place of f of 1/3. So g of f of 1/3 is equal to g of 3. And we'll put that up there. So this is equal to 1 over 3 squared, which is 1/9. So g composed with f of 1/3 equals 1/9. Doing okay? Yes.
So I'm just curious. There's no way to punch this into the calculators that we have for the class, right?
Correct. Sorry, man. You got to do
It's all good. I was just I
Yeah,
thought about, I was like, I don't think I've ever seen a composition symbol on my calculator.
no. So what this is, I assume you're going on eventually to take calculus.
Eventually.
Okay. In calculus, there will be some rather complex functions that we'll have to deal with. And right now we're learning composition. In pre-calc, we learn sort of decomposition, where instead of taking two functions and combining them, we take a complicated function and pull it apart into two separate functions. And then in calculus, we'll learn how to deal with each of those separately. So we can deal with a complicated mess with just simpler pieces. So that's down the road a ways, but that's one of the reasons we're doing this.
Now, if you had a graphing calculator, which I know we can't for the class, I'm just curious because I've never used one. Can you do
Sure.
this stuff on a graphing calculator?
You'd still have to do the work that we're doing, I believe. I don't, at least the graphing calculator that we use, I don't think would allow you to be able to do this by just punching in the numbers. And really, I think it would take longer. If you could, it would take longer to put them into the calculator than to just do it by hand. I mean,
Right.
you know, anyway, okay. Let's see. Oh, here we go. Now, again, f of x equals 1 over x, and g of x equals 1 over x squared. Let's find f composed with g of 5x. So this is equal to f of g of 5x. So g of 5x, g of 5x is 1 over 5x, the quantity squared, which is 1 over 25x squared. All right. So now all of that goes in the place of this. So we've got f of 1 over 25x squared. And that's going to go up in here. F, well, let's see here. We can just go equals 1 over 25x squared. So there's your final answer. Hang on here. No. I did something wrong. Yes, indeed, I did something wrong. Hang on. That's equal to 1 over 25x squared, right? Because this just goes in the place of x, which is 1 divided by 1 over 25x squared, which is 1 times 25x squared over 1, which is 25x squared. There we go. Ignored that 1. All right. Any questions there? Okay. New set of functions. H of t equals the square root of t plus 3. K of t equals t minus 5. We're going to find h composed with k of 18, which is h of k of 18. K of 18 equals 18 minus 5, which is 15. No, it's not. It's 13. Boy. Apparently, I'm out to lunch before lunch. Okay, which is 13. So that goes in the place of k of 18. So this would be h of 13, which is the square root of 13 plus 3, which is the square root of 16, which is 4. So h composed with k of 18 equals 4. Any questions there? All right. using the same two functions, h of t equals the square root of t plus 3, k of t equals t minus 5. Let's find k composed with h of -2. So that's equal to k of h of -2. H of -2 is the square root of -2 plus 3, which is the square root of 1, which is 1. So 1 goes in the place of h of -2. So now we have k of 1. We're going to look up there, which is 1 minus 5 or -4. So k composed with h of -2 equals -4. Any questions there? All right. This says if f of x equals x plus 1 and g of x equals 2x minus 5, show that f composed with g of x does not equal g composed with f of x. So basically we're doing in general what we did way back earlier in an example where I did f composed with g of 2 and then g composed with f of 2 and showed that it wasn't commutative. Now we're going to do it, but just using x instead of a specific numerical value. So f composed with g of x equals f of g of x, which equals f of 2x minus 5, because this goes in the place of g of x. Okay. F of 2x minus 5 would be 2x minus 5 plus 1, which is 2x minus 4. So f composed with g of x equals 2x minus 4. Okay, so far so good. All right, now I'm going to, let's see here. What did I get there? That's where I got 2x minus 4. So now we're going to find g composed with f of x. And that is g of f of x, which is g of x plus 1, right? Because this is going to go in place of that. G of x plus 1 is 2 times x plus 1 minus 5, which is 2x plus 2 minus 5, which is 2x minus 3. So that shows that in general, they're not commutative. And as I said, we'll look at examples tomorrow, specific cases where it is commutative, but in general, it is not. All righty. Any questions at this point? Okay, well, that's it for today. I'll be back at 1:15 with an office hour should you have any questions. And have a great